So NOAA has lots of data, big data, both in the sense of the volume of data, but also the variety, the veracity, the velocity, all that stuff. We've got 10 satellites, we've got weather radars, which we'll talk about a little bit more in a second, but we've also have buoys, tide gauges, human observers, people out there with clipboards counting stuff, or underwater scuba divers, that kind of thing. Sensors on animals, ships that go out and measure things either routinely or have sensors dropped off the side, water collected, brought back to the lab, measured. Aircraft, some which fly into hurricanes, and a bunch of numerical models, weather models and other things. And most of these data are unique, because we're the only ones collecting these particular data sets, and they're very valuable. They cost a lot of money to collect. They can't be replaced. You can't go back and re-measure something once the moment has passed, or at least measure it at that same time. And they're collected at public expense. So you, the taxpayers, are all helping us to do this. And the tagline is the data are from the bottom of the sea to the surface of the sun, because we measure bathymetry down there, but we also observe space weather, solar flares, that kind of thing. So really a huge range of data. So the vision is that all of these data are supposed to be able to be discovered, accessed online, usable once you've found them, and preserved in an archive for future generations for any users. That's the overall vision, and that's kind of what my job is to try to make happen. And the Big Data Project is one approach to addressing the, let's say, the access and usability, especially parts of this. So, before we start thinking about the cloud, what have we sort of been doing? The idea is we've got data sources, the variety of some of the sources that I mentioned before, and then we've got users that are out there. They want to use their own tools. They don't necessarily want to go to some web portal I built. They want to use their software. They want to get it into their decision support tool, whatever. So they just got to get data from us to them somehow. And so we've been working on establishing, let's call it a data services layer. So the idea is that we would have standards-based methods for people to search and discover the data. And then through that, you would find where is the data, and there'd be an access service. And ideally, it's OpenDAP or an OGC service or something that's a standards-based service. And the data are well documented with ISO or FGDC metadata, and they're in well-known formats using controlled vocabularies. So these are the kinds of things we've been working on, and these are very valuable, and we have to keep doing them. But the diagram there suggests that all the data are in this box in the middle, and that's not really true, right? The data are at the sources, and the users are on the other side. So in practice, what really happens is we put up data access services on each of our data sources, and they are sometimes standardized, sometimes not. It depends on the data. And then there's a catalog, a discovery piece kind of floating out there somewhere. We have one. It's at data.noaa.gov, and you can go there, see about 60,000 data sets. And then the users, meanwhile, they've got their own facility and their hardware, and they need to get the data up to their on premises before they can start working with it. So the users are making copies of the data and working on them there. And that's great sometimes, but it's very difficult, obviously, when the data are very large or otherwise hard to get to. So we started this big data project, and this has been a period of time in the works. I think it was in 2014, February 2014, we issued the original RFI, request for information, just to see if industry would be interested in doing anything on this. And the idea was, we've got our data, we've got our Earth observations, we've got our model outputs, and we're going to keep the master copy. We're not, sending only sending the only copy out. We have the master copy. And we're going to keep working on our own services for data discovery and access. But what if we pushed somehow data outside, a copy of the data out into the cloud, somebody's cloud, TBD, where people could write or run functions to analyze the data, to integrate numerous data sets, and to start building custom products and applications like some of the ones that we've been just hearing about now. And then even customize things that are dedicated to specific customers, individual lines of business. Would this create new apps that didn't exist? Would it create new types of business that didn't exist yet? Just like the commercial weather industry sort of sprung up using NOAA public weather data, we have tons of other kinds of data. Are there other industries that could be created? And NOAA is part of the Department of Commerce, so the Secretary of Commerce was among the people championing this idea. So, we had several premises here in the Big Data Project. That, number one, there's more value in the data than what we've already extracted from it. And part of the reason we haven't gotten the value out is because it may be difficult to get to the data, or if it's large, difficult to actually use it. You have infrastructure difficulties. So I think our operational customers are well served. We have the Weather Service, and they routinely get direct feeds as fast as possible of satellite data and buoy data and so forth. Okay, that's great. What about everybody else? And what about all the non-weather data? So second part of the premise is if we put the data in the cloud where you can have computing capability right there, then private enterprise, science, decision support people, anybody might be able to work more easily with data and perhaps generate new value-added products and services. And that even private enterprise, such as the cloud providers, might be willing to support the cost of getting the data into the cloud, knowing that there'd be a way to recoup those costs by actually, for example, selling computing services. And that if we tried this, we might find that it's possible to have a self-sustaining partnership that makes good use of our data and allows new businesses to emerge, and everybody's happy and we keep going. So, we put out this premise. We issued an RFI. We had, I forget how many, we had something like 75 responses, 50 pages each to go through, a lot of very good input. We had an industry day with something like I think 300 participants from 200 companies expressing interest, but also expressing caution and nervousness and not wanting to necessarily, commit too much to this, not knowing if it was going to really pan out. So we decided that the way to move forward with this was with a series of CRADAs, Cooperative Research and Development Agreements. And so these are R&D agreements, which is great because we're not really fully committing ourselves to buying anything. Companies are not necessarily committing themselves to service-level agreements on this from our point of view, but it allows us to try this and see what works and then keep the good stuff. So we ended up signing 5 of these CRADAs because we were trying to also be fair, and it was difficult to know how to actually select any one cloud vendor. So we actually have 5 cloud infrastructure as a service providers: Amazon, Google, IBM, Microsoft, and Open Cloud Consortium, always stated in alphabetical order per the terms of some discussion somewhere. So Amazon, you get to be first. Yeah. So that's good. So, and there's this web page here. Maybe I should put the URL more prominently, but data-alliance.noaa.gov gives you a little bit more information about the overall project. Not a ton more, unfortunately. We should boost up that web page, improve the web page, and it links to websites of each of these groups that are doing something, including Amazon. In fact, from there you can get to the NEXRAD on Amazon. So the idea here is we could form maybe these data alliances where NOAA would work with these 5 R&D partners, and then they in turn would have other partners that work with them to develop products and services or buy products and services that were developed and so forth. And we wouldn't necessarily have to interface directly with those external partners. We just work with the sort of infrastructure provider. Doesn't always necessarily work exactly that way, but that was the concept. So right now we've got these CRADAs that are 3-year projects. They could be renewed. It's technically research, but I have a feeling we're going to find, actually I'm confident that we're going to find that it is so useful that this is going to very quickly transition out of research and into very useful things. I think NEXRAD is in that category, but there's still questions about how do we get data up there in each case and so forth. We were trying to be iterative, start small, let people test the waters before totally committing, use a few initial data sets, and allow especially the collaborators to decide what data they wanted. When we first wrote this down, we said, we'll send all of NOAA's data to the cloud. Well, we're probably not going to do that because not all of the data sets are equally interesting or exciting or marketable, frankly. So we're letting kind of the market determine what data sets. And the first one we've put up there is the NEXRAD level 2 data, which we heard about a little bit before. So NEXRAD is next generation radar. Maybe you've seen these stations, next to airports and so forth. And level 2 means it's been processed into reflectivity. So what is the reflectivity signal that the radar sees all around, both horizontally and then also in a vertical arc. And it's used for weather, severe weather. This is an image of a storm in, is it Norman or somewhere? I can't remember now. But anyway, this is like a tornado image. very critical data for weather prediction and bad weather avoidance and so forth. And the data were available. It's not that you couldn't get them, it's that it was a major, major pain. So you might as well not have been able to get them, okay? It's like saying, yeah, all the data are available, but they're in a filing cabinet at the bottom of a basement, and you have to, submit carbon copy form requests, and we'll get it to you by self-addressed stamped envelope. It wasn't quite that bad. It was on, robotic tape at our data archive, one of our archive facilities in Asheville, North Carolina. So you could get it, but some of it you had to wait until the robotic tape machine goes and gets the tape and reads it and sends it to you, which is fine if all you want is a little bit, station by station, but as we learned, very difficult if you want to get all of it back out. And that, by the way, was a screenshot of our archive webpage where you can still get it. We're not turning off any of our public access services, but this is now going to be a more convenient way to get it. And obviously, you may have seen images like this. This is another way to get it. This is a Doppler, a radar mosaic showing precipitation in the US from about a month or so ago. So the public often has seen the data in this form, but it's been very hard to work on all of the data at once. So now we've copied all of it to Amazon S3. And we started with the data in 91 when the first radar was installed, all the way until now, the present day. So the number of radars has grown. The capabilities of the radars have grown, going from sort of their initial single polarization to a dual polarization, so more data. We read all of the data out of the archive and sent it up to Amazon, which took months. Actually, ironically, half of it was on disk, and that took something like a week or two. I don't know, Ariel, maybe you can remember. So it seemed like, okay, great. We'll get the next half in 2 more weeks, right? Well, no, it took months to actually go and get the data, put it on disk, and then read it up there. Also, Amazon has established a receipt node for a feed from the Unidata IDD LDM, that's Internet Data Distribution / Local Data Manager software, which universities and the Weather Service and others use to ship data around, including this. So now Amazon is getting the current data as well as having all the archive data. And it adds up to more than 270 terabytes compressed, I've been told, which is a petabyte if you were to uncompress it all, so it's a lot of data. And the availability was recently announced, October 27th. Maybe you saw the press release, and I think Jed showed this web page earlier. So it's there. We really encourage people to come and work on it and do good stuff with it. We're now starting to think about what do we do next? What other data sets? And you might have seen the voting out there. Put your Post-its by which data sets you want. It looks like geostationary data is the top one last time I looked. But there's other things. For example, we have this thing called multi-radar, multi-sensor reanalysis, which takes all the radar data and actually puts it into a grid and finds severe weather events. And it's sort of a highly processed version of the radar data, which would be useful for some applications, I think. In the bottom right, we see LiDAR, laser-based measurements, LiDAR point clouds. That could be very interesting to get out there, and it's a rather different type of data. And then numerical models. That is going to be a huge area, and I think was actually the major impetus for this project, because we run these models, we use them to predict the weather, we make some of the outputs available, but we just can't make all of the weather model output available. So, let's say the model predicts, we make available, I don't know, a forecast every 1 hour from the model. Well, maybe the model is putting out something every 10 minutes. So there's these much finer time steps and maybe even finer spatial resolution that nobody can get. It's just there on the computer. I don't even think it stays there permanently. We use it to run the model, and then, okay, we got to get rid of it to make more room. So can we get that out the door so that people can get into it and get some really, fine-grained analysis of the weather? So I think you're going to see data sets like these and other ones either working with Amazon or, some of our other collaborators, because we do have 4 partners on this, getting some of these data sets based on what they feel their customers would be interested in. So as we started this, though, there was kind of a fear that we'd go out of business. We'd just become operators of satellites and we wouldn't have to do anything. What if the cloud providers and their partners can make better weather forecasts than us? What if they do all the data analysis and we don't, we're all out of a job, There was some people expressed concern about that. I personally don't think that's a real concern. we have to worry about, because I think NOAA is still going to have a role even in this kind of new paradigm way of accessing the data. For example, we have to ensure that the data are freely and openly accessible. And there's a federal open data policy, a memorandum from OMB, OMB M1313, which says all government data must be freely and openly accessible unless there's like a legal reason why you can't do that. We also have the authoritative data. So if somebody gets the data from Amazon and makes a derived product, we don't always know, did they do the right algorithm? Is it still the good thing? What did they do? We have the authoritative data, metadata, and the warnings especially. So, we are taking the responsibility, NOAA takes the responsibility of saying, there's a tornado coming, get to shelter, for example. We're not going to give up that responsibility in the hopes that somebody else will provide the warnings. What if they don't have it? We also do a lot of research on our sensors, improving the numerical models, improving the algorithms, and we are guaranteeing to preserve the data essentially forever. We have our long-term archives, and yeah, it's true there's some robotic tape involved, and I'd like us to migrate off of that, and perhaps we will with time. But at least we know the data are always there, and even if there's not a particular market for it at this time. And we do stewardship, sort of maintaining data sets, improving, correcting, if you realize, oh, we had an algorithm, a problem, or a calibration error or something like that, we can go fix things. And then, of course, we have the expertise to work with the data. So a company like Amazon, very great in the infrastructure business, but not necessarily NEXRAD scientists. Well, we've got the NEXRAD scientists, and we can work together. So I feel that roles of an agency like NOAA will continue in this kind of world. So it has been a very interesting project so far, and I think we've learned a lot. We learned some of these things. First, it turned out that there was a lot of behind-the-scenes work to get the data. We didn't realize necessarily it would be like this. We'd just say, well, we've got this data set, just plug in and get it. It's online, just start reading it. It turns out that's not the case. If you really want all of it as fast as you can, and it's a complicated data set, and you want to make sure you get every piece of it, there's a lot of sort of back and forth and kind of weekly telecons to make that happen. We need to monitor the feeds. If it's not a one-time transfer, we set something up and then whoops, the script stopped running, somebody's got to run again, because this is it's not always operational. We have to make it operational if we want to be sure it's really running. A lot of work collaborating with the external collaborators, I think, or communicating with them. I think we kind of went into this thinking, oh, the cloud providers, they will find their partners, and we will talk to 5 cloud providers, and they'll talk to everybody else, and that'll be the end. But in fact, there's frequent discussion that we have to have, which is good. I'm not saying that's a bad thing, but I think there was more than we required. So, we kind of went into this saying, oh, it's going to be at no cost to the government. And it's true, we're not necessarily, putting a bunch of cash behind it, but it is cost in terms of labor of individuals at the agency. And we're very glad to do it, and we're going to continue doing it. But it was, it wasn't quite what we expected, I think. We learned that the private sector moves faster than the government. And there was a surprise about reading things off tape, but, sometimes you could sense the frustration of the private sector. Well, I asked for this yesterday, Jenkins, why don't we have it now? And the government's like, oh, let's set up a committee and talk about it. So things don't always go as fast on the government side as was expected, but I think maybe we're learning how to do things faster and respond to expectations of this project a little bit faster. And then I think also we're learning that even a single data set in the cloud can generate great interest. Now, obviously, this isn't the first data set in the cloud. You've got already the Landsat on AWS, and you saw, I think, that it generated a lot of interest, and you weren't sure going in. Amazon wasn't sure what kind of interest it would generate. NEXRAD is at the infancy stage, right? We've just had this out there. Now you can come start playing with it, and I think it's going to generate some very good work. So closing thoughts, I'm actually going to go back to one slide in a second, but first of all, I think for the science agencies and the operational agencies like ours, cloud technology is going to introduce significant changes. We've been trying to do certain things right and the right way, and I'm not saying those need to stop, but the cloud paradigm is new. And the data volumes are huge, so the idea of bringing the computation to the data is, I think, the way we have to go, absolutely. And so this is going to make a big change in how we do things. But government science agencies are still going to have major roles and responsibilities, and I think these public-private partnerships can leverage each of our expertise. And let me just come back to this for a second. This diagram was shown at the beginning here. There we go. Okay, so I showed this, said, hey, we're trying to get some standardization out there, but the data aren't all in this box, okay? But pretend the data are in this box. Let me pretend there's a cloudy border on the data services box instead of a square border. Okay, now it's the cloud. And let's say the data are out there. I think we're going to start seeing a whole bunch of new questions like, what kind of standardization do we need? Let's say I want to get NEXRAD and Landsat together. Okay, so they're both on S3. That's great. So some of the kind of low-level infrastructure REST API stuff is going to be the same, but do we need other standardization? NEXRAD has its own custom format. It's different from everything else. Landsat, I guess it was TIFF. That's great, but do we need to agree on things like how we organize the data in the cloud? Do we need to agree on the metadata that shows, that describes each one, common vocabularies, that kind of thing? So I think there's going to be an interesting area of starting to integrate multiple data sets in the cloud, because right now these are their own little projects. I don't want to use the word stovepipe because it sounds really bad, but their own little islands to some extent, and I think there's a real opportunity, let's call it, for somebody out there, you folks maybe, to start building the pieces that connect these. Or for example, with the NEXRAD data itself, it's organized by year, month, day, and station, and the station is a 4-letter code, NXQV or something like that. What if I want all the data from one station? Oh boy, now I got to sort of, iterate through all those trees. Or what if I want, what if I don't know the station names? I just want any station that's in this lat-long box. Well, there's no piece right there that lets me discover the data in that way, but that's an opportunity. Somebody could be writing little pieces of code that do that. And I'm not saying Amazon should do it. I'm saying, somebody, NOAA or an external partner could be doing things like that. So I think this is going to open up a whole new arena of exploration and kind of, need for new standardization and new approaches. So I'm going to end there. I'm going to go to the last one because it has my email address and ask if you have any questions or comments. Thank you.
Jeff, I just have a question. So just to be sure I understand, maybe I missed it here, you said, but so are you just supporting kind of computational or analysis services, or are you guys supporting like direct data egress out, like with these projects? Are you looking at that and how you govern that, what the costs are, that sort of thing?
Right. Okay. So stop me, Amazon, if I say anything wrong, but we, NOAA, are not supporting computation except that we're bringing data to be computed on, okay? And my understanding is, at least for the NEXRAD data, the egress is at no charge. So there are no egress charges for the data, either the archival stuff or even the real time. But there may be, I guess there will be a computation charge, sort of per hour CPU charge if you want to compute directly on the data. I mean, and that can be anywhere from, a penny an hour with a spot instance to, at low power to $5 an hour if you really need something right now. But I think it's still worth computing on location than bringing back to your premises, unless you only need a tiny bit maybe. But I think we're going to see a lot more computing. But we're not supporting it. That would be a sort of user pays or application developer pays.
That's what I meant to make the data available to somebody else to compute.
Yes.
I was thinking more in terms of egress and like if somebody, you're right, I agree, it's better to just do the computation
right.
place, but if somebody, you're going to still get people that say, hey, just let me download all of it,
Right.
But, so, okay, so the idea is you guys aren't, so Amazon is letting you do that for,
Amazon is letting other people do it.
Okay, okay.
That's their choice, okay? And that's great. I think the project would be less successful if the only result was we moved the data somewhere and then other people downloaded it to their own facility. I mean, what's the point? So, yeah.
I come from the background of doing ground station work, and I think it's just a matter of time before AWS and companies like Harris and other manufacturers of antenna, they're up, and all the sites around the world that Amazon already has or any other cloud provider become downlink locations, and data gets fed directly into Amazon, and people can tap into the raw satellite data coming down directly from the satellite.
Yes.
And kind of the government get out of the necessarily the business of creating all of these complicated networks themselves, and let that kind of partnership come up and take care of collecting data around the world directly from the satellites.
Yeah, so I agree, at least in part. I think we've got these geostationary or polar orbiting satellites. You could certainly put an antenna on the roof of a data center, anybody's data center, and start downlinking everything and do what you want with it. And that might be the most efficient way to get the data in. Now, that being said, though, NOAA launched these satellites for a reason. We have to do weather forecasting. We have to make sure the data are processed and get into the numerical weather models as fast as possible. And there's kind of strict timelines, like this thing must be there within 13 minutes or we can't use it, kind of thing. So there's some level of operational reliability that we just need to know we have for our mission, which is basically saving lives and property. That being said, there's, I believe, tons of other things you could do with geostationary satellite data, for example, besides forecasting the weather right now. And for those uses, the private sector could well just be getting it directly and working on the raw data from the satellite. It's kind of a pain, right? You got to know how to unpack and everything, but it's not impossible to do. No. Okay, thank you very much.